Alright, so in this video we're going to learn how to use the analytical method in order to add vectors together. And when you're working with distance values, that's actually the same thing as finding the displacement. If you remember from the tip to tail video, when we drew in the resultant vector, we essentially found the distance between the beginning of one vector and the end of the other. And that is the same thing as a displacement when you're dealing with distances. Now you can add other types of vectors together, but conceptually, adding together distances makes the most sense with this process, which is why we're starting with distances. So don't be shocked if you have to add other vector quantities together in the homework. Alright, so the first thing I'm going to do is I'm going to draw my vectors on a coordinate system. So you can see here how I've drawn the coordinate system with the positive and negative y-axis labeled and the negative and the positive x-axis labeled. Now I'm going to switch colors and we're going to draw in our vector. So vector A is 45 degrees above the negative x-axis. So the axis to the left is going to be the negative x-axis and I want to sweep above it. So that's going to put my vector A in the second quadrant. So quadrant 1, 2, 3, and 4. And then the 5 kilometers will be the hypotenuse, because eventually we're going to draw on a right triangle. And then the 45 degrees is this angle that's being swept out. All right, vector B is just straight up because it's in the positive y direction. So this is going to be 7 kilometers. And then vector C is, let's see, it's so many degrees below the positive x-axis. Let's look up how many degrees it's actually supposed to be. 55 degrees. All right, so below the negative x-axis, so that's going to put us down here. So our 55 degrees would be here, and it's 9 kilometers long. Now I want to make right triangles where the magnitude of the vector is the hypotenuse of those triangles. So I'm going to switch colors again. So this is going to be AX because it's on the horizontal, and this is going to be AY because it's on the vertical. And notice I've drawn my right triangle in so that the angle that I'm provided is inside. I want it to be an interior angle of the right triangle. All right, we'll talk about B in a second, and then for C, we're going to have X because that's horizontal, and then Y because this is vertical. All right, so now that I have my right triangles drawn, I need to use my trig functions in order to split them into components. So let's switch back to blue. All right, so AX is going to equal A times the cosine of theta. And I know this because the 45 degrees is adjacent to AX. And the hypotenuse is always going to be the magnitude of the vector. So I'm going to do AX equals 5 kilometers times the cosine of 45 degrees. And I'm going to put that in my calculator and get 3.54 kilometers. And then for AY, that side of the triangle is opposite to the 45 degrees. So I'm going to use sine. So I'm going to do A times the sine of the angle. So 5 kilometers times the sine of 45 degrees, which is going to give me 3.54 kilometers again, because that's something special about the 45 degree angle. All right, so before I move on, I need to check whether any of my vector components are negative. So AX points to the left, that tells me it's negative. AY points up, so that tells me it's positive. So I'm going to put a minus sign out here. All right, now B is special because it only points along the X or Y axis. Since it's pointing in the Y direction, none of the vector points in the X direction. So it tells me BX is equal to 0, and BY is going to be a positive 7 kilometers because it's pointing up rather than down. All right. So for C, we need to go back to our trig components. And I'm going to use cosine for the x component again because it is adjacent to the x component. So the 55 degrees is adjacent to the x component. So I'm going to do 9 kilometers times the cosine of 55 degrees. So that's going to give me an x component of 5.16 kilometers. And then I can do the y component, and this time I'm going to use sine because the y component is opposite of the 55 degrees. So I'm going to do 9 kilometers times the sine of 55 degrees. And that's going to give me 7.37 kilometers. Now I need to check positive or negative again. So this time the x component is positive because it's pointing to the right, but the y component is going to be negative because it's pointing down. So I'm going to put a minus sign in here. All right, so now I've split all 3 vectors into components. My next step is going to be to add together all of the x components to get the x component of my answer. And we label this R because R stands for resultant, which is the mathematical term to the answer to an addition problem. So to get Rx, I'm going to add together all of my x components. So in this case, since we have 3 of them, I'm going to add all 3 together. So I'm going to take a negative 3.54 kilometers plus 0 kilometers plus 5.16 kilometers. So when I add those together, I get 1.62 kilometers. And then to get the y component of my answer, I'm going to add together all the y components. So I'm going to take my 7 kilometers. That's B. I'm going to take my 3.54 kilometers plus 7 kilometers plus the negative 7.37 kilometers. And that's going to total 3.17 kilometers. All right, so we have the x and y component of our answer. Now we need to find magnitude and direction. Now that we have our components of our resultant vector, we need to find the magnitude of the direction of that resultant vector. So I'm going to draw a new coordinate system here. And I'm going to draw in my components. And I always do the x1 first. So I'm going to draw along the x-axis r of x. And then off of the tip of r of x, I'm going to draw r of y, so it's positive y, so I'm going to draw it up. And we end up in the first quadrant. So this will be our magnitude of our vector, which is the hypotenuse of the triangle, and then we're going to find our angle theta here. So we're going to use Pythagorean's theorem in order to find the magnitude of the vector. So we're going to take our 1.62 kilometers squared plus our 3.17 kilometers squared, so that our resultant vector magnitude is 3.56 kilometers. And for the angle, since we have the sides of the triangle, we're going to use inverse tangent. So we're going to do r of y, which is opposite, over r of x. Which means we're going to do 3.17 kilometers over 1.62 kilometers, which is going to give us 62.9 degrees. Now you always have to give a reference point for your angle. And since this angle goes from the positive x-axis and sweeps through to the hypotenuse of the triangle, and the hypotenuse of the triangle tells us the size if it's drawn in a scale and the direction that the vector is going to point in. So if this was drawn in a scale, you'd actually have to get out a protractor and get that angle right and make sure the length of the arrow actually reflects a scaling for the 3.56 kilometers. So since we're going from that positive x-axis up to that hypotenuse, that tells me this is going to be above the positive x-axis. So anytime you are going to have an angle, you do have to define where that 0 point is. So where are you starting your sweep, where are you ending your sweep? So in this case, you're going 62 degrees or 62.9 degrees above the positive x-axis. Now I do want to briefly mention subtraction here. What happens if I had said what's a plus b minus c? The only thing you're going to do that is different is once you get to this step where you have your components, you would flip the signs of the vector that is being subtracted. So since c is being subtracted, I would make this negative, I would make this positive, and I would continue with the component method. So you just flip the signs of the components of the vector that is being subtracted. Everything else is the same as addition for the analytical method.